Okay, so hopefully you guys were here for the chessboard activity we kind of did today. Just a quick refresher. There was a chessboard, and the man said that I'll take as many grains as you can fit on the chessboard, um, as long as you double each square. So, for example, if we just do the first row of that, there's 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so he said he's like you can put 1 grain of corn here, but I want you to double it every single time. Okay, and as you can imagine, this is 8 by 8, so there's a whole bunch more squares. Okay, so yada yada yada. But you can see that it's going to go to 256, then 512, and then 1028, and it's going to get large very quickly. Now I asked you to find out how many grains of corn could fit on that chessboard. Realistically, obviously they couldn't, but this is an interesting math problem that introduces geometric sequences. Specifically, yeah, this is geometric sequences. Geometric because we are multiplying by 2 every time. Later, we're going to talk about arithmetic sequences, which means you add by the same every time, but that'll be later. So let's go over a few things. Finding the sum on that chessboard. Good luck finding that out without a formula, without the formula. It would take way too long. So luckily, we have an equation for the sum of a geometric series, and this is denoted by S sub n. Okay, for the sum equals a times r to the n minus 1 over r minus 1. Okay, or it can be written this way, and I'll explain the difference and which one you should use when. A equals 1 minus r to the n over 1 minus r. Now they look very similar, but if you notice in both of these the 1 and the r are switched around. You will use this one if your r is less than 1, so a fraction or a decimal. Anything else, you would use this one. Okay, so what do these mean? Well, A is the first term in the sequence. Okay, so in our chess problem, this would be 1 because you start with 1 grain of corn. R is the common ratio, okay, or what you multiply by. Okay, you can write that down if you want. It's what you multiply every time. So in our chess problem, okay, let me write this down in our chess problem. Okay, A would be 1 and R would be 2. We start with 1, we multiply by 2 every time. And n equals the number of terms. And for the chess problem, it's 8 by 8. There are 64 squares. So we would be adding this 64 times. So we would use 64 as n. So let's write this out in our formula. Let's not necessarily find it out. I want you guys to do that on your own when you come to class. That's actually what I'm going to ask you for the quick check. So this is going to be the summation, okay, of 64 for this is going to be a, which is 1, and then r is 2. R is 2 raised to the n power, which is 64, minus 1, and this is all over r minus 1. My r is 2, 2 minus 1. So this is how you would set up for that chess problem, and then you have an amazing calculator to do that for you. There would be no way to solve that on your own without a calculator. Okay, so let's go over a different example. Okay, so we want to find out what this equals. Okay, so 4 plus 6 plus 9 plus dot 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 4 times 1.5 to the 10th power. Okay, so if you notice, if you can't tell by here, how we are getting from here to here is that we're multiplying by 1.5. Essentially, we're taking half of this and then adding it to that number. So half of 4 is 2, 4 plus 2 is 6, okay? But this is a geometric series because we are multiplying by 1.5 every time. 4 times 1.5 is 6, 6 times 1.5 is 9, so on and so forth. And we're going to do up until, okay, the 10th, 4 times 1.5 to the 10th power. Okay, so let's write this out. Now here, a lot of people would put, oh, n is 10. Well, actually, n is 11, because people think this, the 10 here, and they think, oh, that means n is 10. But remember the first term? Here, this is 4 times 1.5 to the 0 power. Okay, this is 4 times 1.5 to the first power, and we're doing that all the way up until 4.1.5 to the 10th power. So here's 10, but then we also have to think about this term, which is our 11th term. Okay, and then so this gets 4 is my first term. If you need to go back and look at the formula, or actually here, I'll go back before you. We're going to be using this formula. A is what I start with. So my first term is 4. Okay, and then my common ratio, I'm multiplying by 1.5 every time here. And this is raised to the n power, which I put 11, and I'm subtracting 1 from this. This is all over 1.5 minus 1. Okay, so this is going to be 4 times 1.5 to the 11th power minus 1, all over, I'm going to do this in my head, 1.5 minus 1 is just going to be 0.5. And now your calculator comes in handy. Okay, so I'm going to show you this on the calculator. Here is the problem again that I've set up. Okay, 4 times 1.5 to the 11th minus 1 over 1.5 minus 1. So remember, this is 0.5. Okay, so now let me show you how you would do that on your calculator. So remember, you always do parentheses first. Okay, so we are going to do 1.5 to the 11th power first. So I'm going to do 1.5, hit this x to the y button, that's the power button, and then I'm going to put in the power. Okay, so this long number is what 1.5 to the 11th power is. I'm then going to subtract 1 right there. Okay, so this number is what is inside the parentheses. I am then going to multiply that by 4. Okay, that's what the numerator is. And now I'm left with my denominator. So I'm going to divide by 0.5. Divide by 0.5. And that is what our answer is, 683.98 if we round. Okay, so if we add these up, we get 683.98. Now I encourage you to use the formula to find out how many grains of corn would fit on the chessboard, and that is the answer that you're going to put into the quick check. And you are going to have to use scientific notation. So if your calculator gets you like 1.8 e to the 18th, this is 1.8 times 10 to the 18th power, which means you just move this decimal place 18 times to the right, but instead of writing big numbers, we just use scientific notation.